What's up, everyone? In today's video, we're going to take a look at a problem that might seem a little bit challenging on the surface, but if you just use the axis of symmetry as we've discussed in the previous video, you're going to find that it's actually not too bad. Let's take a look. All right, so we have a graph, a quadratic. Again, this is our parent function. We have y equals ax squared plus bx plus c. Reminder, a, b, and c are the constants or the parameters. A and b are just coefficients in front of whatever x, in front of x squared and x. And then c is going to be our y-intercept. And we know it's going to pass through the points 0, -9, and -1, 9. Now, given that the equation of symmetry, the axis of symmetry, another way of saying that, is x equals 4, let's find a, b, and c. So let's go ahead and write out what the axis of symmetry is. I know that my axis of symmetry is going to be equal to negative b all over 2a. What else do I know? Well, this right here, 0, -9, that is a crucial piece of information because if my x coordinate is 0, and then I have a -9, that means -9 is my y-intercept. That is going to be my value of c. So immediately I know that c is going to be equal to -9. Not only that, but I can now use that in my equation. So if I go ahead and write out y equals ax squared plus bx, I know that c is going to be my y-intercept. So I will have that for my value of c. So let's plug these values in and see what we get. So my y value, my output is 9, and then my input value is going to be -1. So let me put that into here. Now let me simplify. So I'm going to have a minus b minus 9. Let's move the 9 over. Let's isolate for our variables. I'm going to now have 18 is equal to a minus b. So you might be thinking, hey, we're kind of stuck. We have two unknowns, and I don't really know what to do now. Well, if you remember what our axis of symmetry is, negative b over 2a. Look at this. I have a negative b here, and I have a negative b here. And I also know that the axis of symmetry is going to be equal to 4. So let's actually think about this. 4, my axis of symmetry is going to be equal to negative b over 2a. And recognizing that I have a negative b here and a negative b here, I also have a's. I could do this for a, but I'm going to go ahead and solve it for negative b. Because I can go ahead and move 2a over. That'll give me 8a is equal to negative b. And I can now plug in 8a whenever I see a negative b. So when I see a negative b, I'm going to plug in 8a. That's exactly what I'm going to do. And I'm going to do it as a little offshoot here. Let a plus 8a, 18 is going to be equal to 9a, and then a will be equal to 2. I just solved for a, and now I can go ahead and solve for b right over here, actually, because I know that a is going to be equal to 2. I don't know what b is. 16 is negative b, so negative 16 equals positive b. So now I know what my final equation is. Y is going to be equal to a, 2x squared, plus bx. b is negative 16. And then I have my value of c right there. So this type of problem might not seem really straightforward when you're writing it out, but if you just write out your equations, whether it be the parent function or the equation for the axis of symmetries, and you plug in the missing values and you see what, I saw that I have a negative b here, I saw that I have a negative b here, or maybe I want to solve for a and a, you can find that it's actually really not that complicated on the math front. It really is just kind of these 2-3-step equations, but the approach is just a little bit different. So always write out everything that you're going to need on your paper and then solve it step by step. All right, so I hope that sheds a little bit of light into a problem like this, and I'll see you all in the next video.